Design problems are very common during software development. How do you choose the right software or a technology? How do you select the most suitable algorithm or the data structure? How do you optimize for performance? How do you ensure maintainability and scalability of the software? These are some of the design problems that could arise when you're building a software. Now, how do we solve from them? Let's find out. So, what are patterns? Architecture patterns. Let's think about it. So, if you talk to a human being, we generally have a knack for finding patterns, right? If you show us clouds, we'll try to find shapes. I as a kid used to look for shapes in rivers when throw stones. If you find the night sky, we'll connect them with lines and call them zodiac signs. We are creatures of patterns, and software architecture is no different. Architecture patterns are overused, or I don't think overused is a good word or to define. They are reusable practices, they are reusable solution to recurring design problems. That's what a software architecture is. So I will repeat, recurring design problems have a solution that is called software architecture patterns. Now there's design patterns and then there are architecture patterns. We are going to be talking of architecture patterns. The difference lies in the abstraction. Architecture pattern is still at the top, while design patterns are more granular and help you make more day-to-day choices. Some of architecture patterns are layered architecture, client server, microservices, microkernel, MVC, event driven, and so on and so forth. There's tons of different architecture patterns that we'll talk about in future videos. Now, how do we decide and select an architecture, right? Now, that's something that is very, very important to understand. If you don't know how to select an architecture pattern, then you would probably take a pattern which is incorrect for your problem, and then you are for a toss, right? You have implemented something which is a high level solution but doesn't fit in your ecosystems. Let's try to see some observations, some best practices that could help you design and select good architecture patterns. Number one, requirements and constraints. I cannot emphasize on this any further that requirements are the most important things to talk about and think around. What are your constraints? What are your quality attributes? What are your non-functionals? Try to write them down. If you do not do that, then you have basically took a solution without understanding the problem. Understand the problem and then go in the solution. So number one, requirement and constraints. Constraints are just non-functionals, by the way. Domain and problem complexity, right? Certain domains could be extremely complex. For example, if you're trying to design a banking system and ERP where there is a large, complex, scalable system, a microservice architecture might be good, right? Now, if security is important, you might want to go for a simpler monolithic architecture. So it really depends on what's the domain that you're trying to do and what is the pattern prescribed. There are pattern specific architectures which we'll cover in future videos to hook up onto it. Expertise, right? What is expertise? It's basically your team's capability to be able to build on something. If you don't have that capability, then well, you're for a toss. So you need to assess your team if they're good fit. For example, your developers understand 12-factor apps when working with microservice based architecture. Your developers understand scalability constructs when working with caching solution or distributed systems, right? So that's team expertise. Number four, integration with other systems, right? More often than less, systems and data is consumed than produced, right? You don't have data producers that much more, you have data consumers. So data producers would be sitting up top, but there will be different system doing a lot of MIS, analytics, different transaction processing, so on and so forth. So it's important to understand that how are you integrating with the ecosystem and hence selecting a pattern. Number five, scalability and performance. Performance and scalability is something that is usually critical for any system. Now, when you're building distributed system, when you're building large scale systems, this becomes paramount. Why? Because, well, your boss asks for it, right? So scalability and performance is something that you should go define, measure. How do you define scalability? How do you measure performance? We'll talk about in future. Testability of the system. You heard me right. Testability is often ignored but extremely important. The ability, and I'm not talking testing from a functional perspective. I'm talking testability from an architecture perspective. The pattern that you have implemented, you must have the skills to test it. For example, if you have built a system with 40 microservices, you should have a quality environment which can support 40 microservices and test it. You must test your high availability. You must test your disaster recovery plans. You must test your backup plans. If you don't test them out, then you have implemented something which you are not yourself sure about. So that's software architecture patterns in a nutshell. Stay tuned in to Cafe.io. Look for future videos. Subscribe. Bye-bye.